Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. This is part 4 video on the chapter of playing with numbers where I will solve some 11 illustrative problems on the topic of tests of divisibility that I have discussed in the previous part 3 video on the chapter of playing with numbers. If you have not watched the part 3 video, uh, where I discussed about tests of divisibility of numbers, then I strongly suggest that you watch that video also to have a good understanding of the topic of tests of divisibility. So this video is part of the playlist CBSE Maths for Class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future video. So let's get started with today's video. Okay, so I have the set of 11 problems on the topic of tests of divisibility on the left hand side. I hope the fonts are quite big enough so that you can read it properly while I will solve the problems. And this question paper, the link of the PDF of this question paper will be there in the description below. So while I will be solving the problem, you can pause the video and take screenshot of the solution for your future reference. Okay, so let's start solving the problems. Problem number 1 says, if 19A92 is divisible by 36, where A is any digit, then the value of A is. So it is given that the number, the 5-digit number 19A, A is a digit, it is unknown, 19A and 92. This is divisible by, it is given divisible by 3. Now we know that any number is divisible by 3 if the sum of the digits of the number is divisible by 3. So this implies we must have 1 plus the sum of the digits is 1 plus 9 plus A plus 9 plus 2 must be divisible by 3. So this implies 1 plus 9 plus A plus 9 plus 2 is 10 and 21. So we must have 21 plus A must be divisible by 3. Now what can the value of A be? Now A is a digit, so it can have values from 0 to 9. Now 0 to 9. So now 21 plus A, A could have been 0. If A is 0, then 21 is obviously divisible by 3. But the option 0 is not there in the choice. So you have to check. A can be 3. If A is 3, then 21 plus 3 is 24. A equals to 3 implies 21 plus A is equal to 21 plus 3 is equal to 24, which is divisible by 3, and no other choice. If you take 5, then 21 plus 5 is 26. It is not divisible by 3. If you take 6, 21 plus 6 is 27. It is also divisible by 3. Okay. If you take 1 is not divisible by, if you take A is 1, then 21 plus 1 is 22, which is not divisible by 3. Oh, sorry. And the problem is if 19A92 is divisible by 36. Sorry, I'm really sorry. Now 36. Now if it is divisible by 36, sorry, my mistake. I read the question incorrectly. Okay, so this is the so it is given that 19A92 is divisible by 36. Now 36 means it is 4 multiplied by 9. So this will imply that 19A92 must be divisible by both 4 and 9. Must be divisible by both 4 and 9. Now, here is the thing that 36 is 4 into 9. 36 is also 2 into 8. Let's say 2 into, it is also 36 is also uh, 3 multiplied by 12. 3 multiplied by 12. Now, if you consider 36 as 3 multiplied by 12, then the number 19A92 must be divisible by both 3 and 12. Now, 12 is nothing but, this is nothing but 3 into 3 into 4. Now, a number divisible by 3 and 12 also means that the number is divisible by 4 and 9. So basically, it is coming that if it is divisible by 36, any number is divisible by 36, which means that it must be also divisible by both 4 and 9. So this is divisible by 4 and 9. Now, okay, so the criteria for a number to be divisible by 4 is that the last two digits must be divisible by 4, and we can clearly see that the last two digits is 92. The number formed by the last two digits must be divisible by 4. Then that number is divisible by 4. In this number 19A92, the last two digits is 92, 9 and 2. So the number formed by the last two digits is 92, which is divisible by 92 is divisible by 4, because this is 4 multiplied by 23. 92 is 4 into 23, which is divisible by 4. So clearly the given number 19A92 is divisible by 4. Now we have to check that the given number must be divisible by 9. So we must have 19A92 is divisible by, we must have divisible by 9. Now this implies, we know that a number is divisible by 9 when the sum of its digits is divisible by 9. So we must have 1 plus 9 plus A plus 9 plus 2 is divisible by 9. This implies 21 plus A must be divisible by 9. Now this implies, since the digit A, the next number, what can the least the only value that A can have, A is a digit from 0 to 9. A is a digit from 0 to 9. A lies between 0, not between. A is the value which can take values from 0 to 9. Now, so what can A can take only one value, for which the 21 plus A will be divisible by 9. Obviously, this implies that A has to be equals to 6, which A has to be equals to 6, because 21, if A is 6, then 21 plus 6, 27 is divisible by 9, because the next number after 21 which is divisible by 9 is 27. So for that, to make 21 plus A equal to 27, A has to be 6. A has to be 6. Now there is no other value of A which will make 21 plus A divisible by 9. So we clearly see that A is equal to 6. So the answer is choice C. Answer is choice C. Let's do problem number 2. It says, which of the following numbers is divisible by 99? Now, a number n is divisible by 99, this implies that number n is must be divisible by 9 into 11. 99 is 9 into 11. So we can say that number n must be divisible by 9 into 11. This implies that number n must be divisible by 9 and 11. 9 and 11. So we have to now what is the criteria? Okay. So now we have to check of all the numbers which are given as the choices where it is divisible by both 9 and 11. So now, okay, so let's see choice by choice. Let's see the choice A. The number is 1913462. Now the sum of the digits is 9 plus 1 plus 3 plus 4 plus 6 plus 2. This is equal to 10, 13, 17, 23, 25. 25. This is equal to 25. And this is not divisible by 9. This is not divisible by 25 is not divisible by 9. So definitely we can say that since the sum of the digits of the given number is not divisible by 9, hence the number itself will not be divisible by 9. So this is not a correct choice, because the number has to be divisible by both 9 and 11. We have to check for the divisibility of both 9 and 11 for the number, and we see that the number 913462 is not divisible by 9 because the sum of its digits is 25, which is not divisible by 9. Okay, so we can right away eliminate the choice A. Let's see what is 1, 1, 4, 3 and 4, 5. The sum of the digits is 1 plus 1 plus 4 plus 3 plus 4 plus 5, which is equal to 2, 6, 9, 13, 18. Now 18, the sum of the digits is coming out to be 18, which is divisible by 9. Hence this number is divisible by 9, that is 114345. The given number is divisible by 9. Now we have to check for the divisibility by 11. So we have to mark to check the divisibility of a number by 11. We have to find the value difference of the sum of the digits at the odd places and the sum of the digits at the even places, and that difference, whatever that value is, that has to be either 0 or divisible by 11. So let's mark the digits at the even at the odd places by double line, and we have this, and let's mark the digits of the number at even places by a single line, and we have this. So we must have let's see what is the difference of the sum of the digits at odd places and the sum of the digits at even places. So we have sum of the digits at odd places is 1 plus 4 plus 4, and the sum of the digits at the even places is 1 plus 3 plus 5. So this is equal to 9 minus 9 is equal to 0. 9 minus 9 is equal to 0. So this implies so since the sum of the digits, the difference of the sum of the digits at the odd places and the sum of the digits at the even places is 0, we can say that the number is divisible by 11. Is divisible by 11 because we know that for a number to be divisible by 11, the value of the difference, the difference of the sum of the digits at odd places and the sum of the digits at the even places, it has to be either 0 or a multiple of 11. So we are getting for this number that value is 0. So this is a number which is both divisible by 9 and 11. and hence it will be divisible by 99. So the correct choice, since all the choices, all the problems are MCQ, only one choice is correct. So we need not check the choices C and D. So the correct choice is B. Okay, let's do problem number 3. Which of the following can be the value of A in 7878A? That is 78A is the 3-digit number which is divisible by 3. So the 3-digit number is given by 788, and if it is divisible by 3, then the sum of the digits must be divisible by 3. So it is given that 78A is divisible by 3. This implies 7 plus 8 plus A is divisible by 3. This implies 15 plus A is divisible by 3, and it is asking the value of A. What can the value of A be? So that the number 778A is divisible by 3. So we have to now find, so for the number to be divisible by 3, the sum of its digits must be divisible by 3, and the sum of the digits is 15 plus A. Now 15 plus A must be divisible by 3. So this implies that A can be 0. A can be 0. Now what are the possible values of A which will make 15 plus A divisible by 3? A can be 0 because 15 plus 0 is 15, which is divisible by 3. And then the value of A can be 0 plus 3, that is 0 plus 3 and 3 plus 3. Since A is a digit, these are only the possible values of A. We can also have 3 plus 3 plus 3. So 9. So 0, 3, 6, 9 are the possible values of A. That will make 15 plus A 15 plus A divisible by 3. So the choices are A, 3, B, 6, C, 9 and all of these. So obviously the correct choice will be D, that is all of this. 3, if you A can be 3, if A is 3, then the 15 plus 3 is 18, which is divisible by 3. Similarly, if A is 6 or 9, the sum 15 plus A will be divisible by 3. So the correct choice is all of this. Okay, let's solve problem number 4. Problem number 4 says, if a number x is divided by 5, leaves a remainder 3, then units digit of x is either, okay, we have to find the units digit of a number x if that number x when divided by 5 leaves a remainder of 3. Now, okay, now what can we say about the units digit of a number if the number when divided by 5 leaves a remainder of 3? Now let's say the number b, without any loss of generality, we can assume, let's say the number is x. Let's say let x is the number a, b, c, where c is the digit at the units place. Okay, now ABC is equal to, we can say that AB multiplied by 10 plus C. We can say that from the general form of numbers, we can say this. Now, okay, so where ABC are some digits. Now, so we have now we can see that this implies if we divide this number ABC, that is the number x x we have assumed to be the number 3-digit number ABC, where ABC are some digits. Now I could have also taken the x to be a 4-digit number, or two-digit number, or 5-digit number. The logic would be same. I'm just considering it as a 3-digit number. So ABC, in if I do a little bit of expansion using the general form, it will be AB into 10 plus C. This implies divided by 5 ABC, if I divide, that is the number x, which is ABC, if I divide the number by 5, it will be AB multiplied by 10 divided by 5 plus C divided by 5. Now this is equal to twice of AB, 2 into B. AB is the 2-digit number, and I have C divided by 5. Now it is also given that when x is divided by 5, it leaves a remainder 3. Now that remainder, the remainder when x is divided by 5, as we can see, will depend on this value, because 2 into the number AB is a so ABC divided by 5, is coming to be 2 into the number formed by the 2 digits AB, plus we are having C divided by 5. So the remainder can only come from this expression. Remainder will if at all ABC divided by 5, if at all it leaves some remainder, that remainder must come from C divided by 5. So this implies that C divided by 5, where C is the unit digit in the number ABC, where ABC is we have assumed to be the number x. So this implies C divided by 5 must leave a remainder 3. So this implies what can the value of C be? C is a digit, such that when it is divided by 5, it will leave a remainder of 3. The possible values of C can be 3, or C can be 3 plus 5, that is 8. Now there are no other possibilities, because C is a digit it has values from 0 to 9. So these are the two possible values of C, which is the unit digit of the given number x, that will leave a remainder 3 when the given number x is divided by 5. So the answer will be choice B. B is the correct choice, that is 3 or 8. Okay, let's do problem number 5. Find the value of x if 49x86 is divisible by 11. So it is given that the number 49x and 86 is divisible by 11. Then we have to find the digit x. We know that a number is divisible by 11 if the difference of the sum of its digits at odd places and the sum of its digits at even places is either 0 or a multiple of 11. So let's see what is the difference of sum of its digits at odd places and the sum of its digits at even places. So the digits at the odd places of the given number are, let's mark them by double underline, and the digits at even places, let mark them by a single line. So we must have 4 plus x plus 6 minus 9 plus 8 is equal to 0 or multiple of 11, multiple of 11. So this implies we get 10 plus x, 10 plus x minus 17. Okay, 10 is equal to 0 or multiple of 11. So this implies we must have x minus 7. This value must be equal to 0 or multiple, that is x minus 7 must be 0 or it must be a multiple of 11. So this implies now x is a digit. X is a digit and x is a digit. So this implies if this implies x can be 7, because if x is 7 then x minus 7 is 0 So one possible value of x is 7. Now can it have any other value such that x minus 7 is a multiple of 11? Now let's see if let's check if x can have any value such that x minus 7 is a multiple of 11. Now for x minus 7 to be a multiple of 11, let's say it cannot be x minus 7 cannot be a multiple of 11, as max value of x can be 9. X is a digit, so it can have values from 0 to 9. So its maximum value is 9. As max value of x equals to 9, this implies x minus 7 that is a max value of x minus 7 is equal to 9 minus 7 is equal to 2. So x minus 7 can only, the maximum value it can have is 2, and so it will never be a multiple of 11, but x minus 7 will be 0 at x equals to 7. So we can say that if x is 7, then the given number 49786 will be divisible by 11. So the correct choice is D. D is the correct choice. Okay, let's see question number 6. If 8xy0 is divisible by 22, then value of x minus y. A number is given that 8x, y and 0. So this is a 4-digit number. It is given that this number is divisible by 22. So whenever you are given any number which is greater than 11, so we have studied that the divisibility tests of divisibility of numbers like from 2 to 11. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Beyond 11, we are not aware of any rules. But so any number beyond 11, you have to check whether that number can be factorized into some two factors, where the factors will lie between 2 to 11. Then we can apply the concept that if a number, so for example in this problem, if this number has to be divisible by 22, then the factor of 22 is 2 into 11. Then this number must be divisible by both 2 and 11. So this is the concept to be applied. So this implies that 8x 0 is divisible by 2 and 11, as 22 is equal to 2 into 11. So this number 8xy0 must be divisible by both 2 and 11. Now we can clearly see that the number 8xy0 is divisible by 2 because the digit at the units place is even, that is 0, which is even, is divisible by 2 as unit the unit digit 0 is even. A number is divisible by 2 when the digit at the units place is an even digit, that is 0, 2, 4, 6, 8. So this is number is divisible by 2. So one condition is satisfied, but this number must also be divisible by 11. Okay, so for that, to check the divisibility, if we apply the rule of divisibility by 11, then we must have the sum of the difference of sum of the digits at odd places and the sum of digits at even places must be equal to 0 or a multiple of 11. So let's mark the digits at the odd places by double line, and we have the digits at even places marked by single line. So this implies 8 plus y minus x plus 0 is equal to 0 or multiple of 11. So this is the condition that the number, given number, will be divisible by 11. So this implies that 8 plus y minus x is equal to 0 or multiple of 11. So if we can rewrite this as, we can say 8 minus x minus y is equal to 0 or multiple of 11. So if this expression, that is 8, this result, that is 8 minus x minus y is equal to 0, then the given number will be divisible by 11. Also, if this expression, that is 8 minus x minus y, is a multiple of 11, then also the given number will be divisible by 11. So this implies that x minus y is equal to 8. This will make, if x minus y is equal to 8, then we will get 8 minus x minus y equals to 0. So this implies x minus y is equal to 8. This is one value of x minus y that will make the given number to be divisible by 11. And what else? Also is equals to 8, or we can say that 8 minus x minus y is a multiple of 11. Now what can, now x minus y equals to 8 is one choice, the value of x minus y is equals to 8 is one possible condition that will make the given number divisible by 11. And also we can see in the choice given, we are seeing the choice D is 8. So we can right away select the choice D as the correct choice. But just for explanation, let's see if the expression 8 minus x minus y, can it be a multiple of 11 for some for some values of the digits x and y. Now x and y are digits, their values can be their values are from 0 to 9. Now is there any combination of values of x and y, the digits x and y, that will make 8 minus x minus y a multiple of 11? So 8 minus x minus y is equal to, we can say 8 plus y minus x. Now can we have any value of x and y such that this expression 8 plus y minus x will be a multiple of 11? Can we make it 11? Multiple of, let's think of the multiple of 11. The first number, which is multiple of 11, is 11. Can we make 8 plus y plus minus x equal to 11? In that case, uh, we cannot have, it cannot be 11. Can we have 11? If you take y as 4, and if you take y as so y minus x, so 8 minus okay, so 8 plus y minus x must be this thing. 8 plus y minus x should be a multiple of 11. Okay, it is asking the value of x minus y. Now if you have to find the value of x minus y, now okay, so I don't think so the condition we have found is that this is the condition, that is 8 minus x minus y has to be either 0 or a multiple of 11. Now if 8 minus x minus y is equals to 0, we are getting x minus y equals to 8. So x minus y equals to 8, this is one condition that will make the given number divisible by 11. The other possibility is if we can make 8 minus x minus y 8 minus x minus y can never be a multiple of 11 for now. Instead of I think instead of applying the logic this way, let's do it. So we must have that 8 minus x minus y equals to 0, or 8 minus x minus y will be must be a multiple of 11. Now we can clearly see that if x minus y is equal to 8, then 8 minus x minus y is equal to 0. So 8 is the value of 8. The value of x minus y as 8 is a possible choice. Now can the value of x minus y be 0? Let's see. So for this, let's see the choice A. X minus y equals to 0 will imply 8 minus x minus y is equal to 8, which is not equals to 0 and which is not a multiple of 11. So now we have already solved the problem. We can see that 8 minus this expression is 0 when x minus y equals to 8, and we have the choice D as 8. So at this point we can clearly select the choice D as the correct choice. But I am further discussing the fact that why the other choices A, B, C will not make, if the value of x minus y is either 0 or 1 or 11, it will not make the given number divisible by 11. So if x minus y for the choice A, if x minus y equals to 0, we are getting 8 minus x minus y as 8, which is not equals to 0 and it is not multiple of 11. So x minus y equals to 0 will not make the given number, that is 8x by 0, divisible by 11. The choice B, you can see that x minus y equals to 1 implies 8 minus x minus y is equal to 7. This 7 is not equals to 0, and also it is not a multiple of 11. And 11, if x minus y is equal to 11, this will imply 8 minus x minus y is equal to 8 minus 11, which is a negative number. This will definitely not work. So the correct choice is obviously D, that is the value of x minus y should be 8, so that the given number 8x by 0 will be divisible by 22. Okay, let's solve problem number 7. For a digit a, which of the following is divisible by 11? Okay, so we have to check all the choices and see which choice, the number given in which choice is divisible by 11. Is divisible by 11. Now we know the rule of divisibility by 11 is that. So let's say this is the number AAA. The choice A is the number given in choice A is AAA. If you mark the digits at the odds places and even places, we can see the difference of the sum of the digits at odd places and the sum of the digits at even places is A plus A minus A. This is equal to twice of A minus A. This is equal to A. Now it has in the problem does not say anything about the digit A, so it should work for any digit A. It should work for any digit A. For a digit A, which of the following is divisible by 11? Okay. Now for the choice A, that the number is AAA and the value of the sum of the digits, the difference of sum of the digits at odd places and the sum of the digits at even places is coming out to be A. Now this has to be equal to 0 or multiple of 11. Now A cannot be a multiple of 11 because A is a digit. Its value it can have values from 0 to 9. So A can be 0. A can be 0. If A is 0, then the number AAA becomes 0, which is obviously divisible by 11. Now let's see what is B. Then which of the following is divisible by 11 for a digit A? Now for B, the number is AAAA. So the difference of the digits at odd places, the difference of the sum of the digits at odd places and the sum of the digits at even places becomes A plus A minus A plus A. This is clearly 2A minus 2A. This is clearly 0 irrespective of the digit A. So it will not matter for the number AAAA, for the 4-digit number where all the digits are A, and it will be always divisible by 11 irrespective of whatever the digit A is. As we can see that the difference of the sum of its digits at odd places and sum of its digit at even places is coming out to be 0, which is independent of A. So this number AA will always be divisible by 11, whereas for the choice A, AAA, it will be divisible only if the digit A, the value of A has to be 0. If A is 1, if A is 1, then the number AAA 111 will not be divisible by 11. Since the problem has said nothing about the digit A, it has to work for any digit A. And for the choice B, the 4-digit number AAAA, we can see it is divisible by 11, which is independent of A. A can take any digit. So the correct choice obviously has to be choice B. Now let's see the other choices as well. C, it is a 5-digit number where all the digits are A. So let's mark the digits at the odd places and even places. And let's see the difference of the sum of the digits at odd places and sum of the digits at even places. We get A plus A plus A minus A plus A, which is equal to thrice A minus twice A, which is equal to A, which depends on A. So this number, 5-digit number where all the digits are A, will only be divisible by 11 only if the digit A is 0. So it will not work for any digit n. So clearly we can see that the correct choice is B. The correct choice is B. Okay. Let's see problem number 8. It says for a number n, if n divided by 5 leaves the remainder 3 and n divided by 2 leaves the remainder 0, then n divided by 10 leaves the remainder of. Okay, so there is a number n and it says that n divided by 5 leaves remainder 3. Leaves remainder 3. So this will clearly imply that if any number, this implies that, please note one thing, that if you have some number, let's say having some, let's say it could be 2-digit number, 3-digit number, or 4-digit number, that does not matter. Let's say there is a 3-digit number xyz. If this number when divided by 5 leaves a remainder, whatever let's say divided by 5 leaves remainder let's say r, this will imply that z divided by 5 leaves a remainder r. The remainder r, when the number xyz, where z is the digit at the ones place or units place, when this number xyz is divided by 5, whatever remainder, if it leaves a remainder, that remainder will depend entirely on the digit at units place, that is, it will depend on z. So this will imply that z divided by 5 leaves a remainder of r. So now we see that n divided by 5 leaves remainder 3 will imply that units digit of n, units digit of n when divided by 5 leaves a remainder of 3. The fact that n, when n is divided by 5 leaves the remainder 3, the remainder 3 will depend entirely on the units digit of the number n, and that units digit when divided by 5 has to leave a remainder of 3. Now any digit when divided by 5 leaves the remainder 3 implies that that digit has to be 3 or 8. So we can say that units digit of n is equal to 3 or 8. 3 or 8. So this is one fact that we have found from the given fact that n divided by 5 leaves the remainder of 3. Now it is also given that n divided by 2 leaves remainder 0. Now a number divided by 2 leaves the remainder 0 means that number is an even number. This means n is even. Any number when divided by 2, any even number will be perfectly divided by 2, which means in the division there will be no remainder, which means that number, any even number, always ends with a even digit. Hence we can say that the number n is even. This implies that units digit of n is even. This implies that, and from the previous fact we have found that the units digit of n is either 3 or 8. So this implies, we can clearly say now that units digit of n is equal to 8, because 3 is not an even digit. 8 is an even digit. So from the two facts that the units digit of n is either 3 or 8, and also the fact that the units digit of n is even, we can say that the units digit of n has to be 8. Okay, so if units digit of n is 8, so this implies n divided by 8, 10 will obviously leave remainder as 8, since the units digit of n is 8, will leave remainder of 8. Now when a number is divided by 10, uh, the remainder it leaves is basically nothing but the units digit of the number. If you consider any number 1, 4, 3, if you divide by 10, leaves a remainder 3, which is the digit at the units place. Or in general you can say xyz divided by 10 leaves a remainder which is equal to the digit at the units place, that is, it will leave a remainder z. So 8 is the correct choice. 8 is the answer. That is, the correct choice is D. D is the correct choice. Okay, let's do problem number 9. A 3-digit number 2A3 is added to 326 to give a 3-digit number 5B9, which is divisible by 9. Then the value of B minus A is. Okay, so it is given that we have a 3-digit number 2A, A is some digit, which when added to 326, it gives a 3-digit number 5B9. 5B9. This is one fact given, where A and B are some digits, we don't know. And it is also given that 5B9 is divisible by 9. Now a number is divisible by 9 when the sum of its digit is divisible by 9. So this will imply that 5 plus B plus 9 is divisible by 9. This implies 14 plus B is divisible by 9. Now what can the value of B be? B is a digit. What can the value of B be such that 14 plus B is divisible by 9? The next number after 14 which is divisible by 9 is 18. So this implies B must be 4. B cannot be any other value. The next number of B, the next value of B after 4, that will make 14 plus B a multiple of 9 will be 4 plus 9, that is 13. So but B is a value from 0 to 9. So the only possible value of B is 4. So we found that B is equal to 4. Now we have to see if B is 4, what we are getting. This implies that twice of A, if we use the first fact, it is given that twice 2A3 plus 326 will now become, we have found B. So it will be B 5, 4, 9. So this implies twice 2A3 is equal to 5, 4, 9 minus 3, 2, 6, which is equal to 3, and we have 2 and 2. From this, by comparing the digits, we can clearly say that A is equal to 2. A is equal to 2. This implies we have to find the value of B minus A. B minus A is equal to 4 minus 2, that is 2. So 2 is the value of B minus A, and the correct choice is B. B is the correct choice. Okay, let's do problem number 10. If 1 by 3 by 6, so we are given a 5-digit number 1 by 3 by 6, 1 by 3 by 6, this is a 5-digit number which is divisible by 11, then the value of y is, the digit y is occurring 2 times in the given number. It is given that this number is divisible by 11, is divisible by 11. Now we have to find the digit y, and we know that a number is divisible by 11 when the difference of the sum of its digit at odd places and the sum of its digit at even places is either 0 or a multiple of 11. So if we mark the digits at the odd places and we mark the digits at the even places, we get the difference of sum of the digits at odd places and the sum of the digits at even places is 1 plus 3 plus 6 minus y plus y. This must be equals to 0 or multiple of 10, multiple of 11. Now this implies 1 plus 3 plus 6 is 10. 10 minus twice y, this must be equals to 0 or this value, that is 10 minus twice y, must be multiple of 11. Multiple of 11. So this implies your 10 minus 10, 10 this implies if we solve 10 minus 2y, 10 minus 2y equals to 0 implies 10 equals to 2y. This implies y equals to 10 by 2, that is 5. So this implies y is equal to 0. So for the value of y equals to 0, we will have 10 minus 2y equals to 0. So y equals to 0 will make the given number are divisible by 11. Divisible by 11. Or we can say that y equals to 0. This is one condition which will make the given number divisible by 11. Also we can say that if we can make 10 minus 2y a multiple of 11. Now can there exist any value of y where y is a digit whose value is from 0 to 9? Can we consider any such y, any digit y such that 10 minus 2y will be a multiple of 11? Can it be 11? It cannot be. 11. So 10 minus 2y a multiple of 11. Can this be ever true for is there any value of y where y is a digit which will make 10 minus 2y a multiple of 11? There is no such value of y because 10 minus 2y is always this is false. This is false because 10 minus 2y will never be a multiple of 11 because as 10 minus 2y is always less than equals to 10. Will always less than equals to 10 because 2y is the value of y is 0 to 9. So you are subtracting the subtracting 2y from 10. So the value of 10 minus 2y will always be less than equal to 10, and so it will never be a multiple of 11. So the only choice, the only value of y that will make the given number divisible by 11 is y equals to 0. Y equals to 0. So the correct choice is sorry, what I am doing, y equals to 5. Sorry. 10 minus 2y will be 0 when y is equal to 5. When y equals to 5. So y equals to 5 is the only value. Okay. So the correct choice is D. D is the correct choice. Okay. Let's solve the last problem, that is problem number 11. It says if we are given a 6-digit number, that is 5, 6, x, 3, 2, y. If this number is divisible by 18, then the least value of y. We have to find the least value of the digit y so that this whole number, this 6-digit number is divisible by 18. Now we have to factorize 18 to some factors which will lie, where the factors will lie between 2 to 11. Is given that this number is divisible by 18. 18 we know is 2 into 9. 2 into 9. Now, and the question is, how do we factor? How do we factorize 18? 18 can also be 6 into 3. 6 into 3. Now, 6 into 3. Now, but 6 into 3, you have to factorize. The idea is, whatever the number is divisible by some number given, that number you have to factorize into factors such that no two factors will have a common factor. If you factorize 18, if you factorize 18 is equal to 6 and 3, then obviously 6 and 3 has a common factor of 3. But 18 equal 2 into 9 does not have any common factor. So always factor the given number, that is the number which is divisible by in the problem. It will be given that some number is divisible by some another number. That another number you have to factorize into factors such that those factors will not have a common factor. So in this case, we will factorize 18 as 2 into 9. So this will imply that the number 5, 6x, 3, 2y is divisible by both 2 and 9, is divisible by 2 and 9. Now, okay, so if this number is divisible by 2, definitely the y, that is the digit at the units place, has to be even. So this implies that y is even. This is one fact we have found. One result we have found that the digit y, that is the digit at the units place of the given number, has to be even, that is 0, 2, 4, 6 and 8, for the entire number to be divisible by 2. But the entire number will also need to be divisible by 9. So this is one result. Now for the number to be divisible by 9, we must have the sum of the digits must be divisible by 9, that is 5 plus 6 plus x plus 3 plus 2 plus y is divisible by 9. Only then the given number will be divisible by 9. So this implies the sum of the digits is 11, 14, 16, 16 plus x plus y is divisible by 9. Now we have to find the least value of y. So we have to find the least value of y so that 16 plus x plus y is divisible by 9, and we know that x and we also know that y is a even digit. Now the fact that y is even, the possible values of y can be 0, 2, 4, 6 and 8. Now if y is 0, if y is 0, then 16 plus x plus if y equals to 0, then we can say that 16 plus x plus 0 is divisible by 9 when x will be equal to Now, if you consider y to be 0, then what can we have values of x such that 16 plus x will be divisible by 9? Of course, we can have x as 2. We can have x as 2. This implies x will be 2. So if we consider y is equal to 0, x has to be 2. So that the given number 5x, 56x, 32y will be divisible by 18. And so this is one solution of x and y, that is y is 0 and x equals to 2. Now we are asked to find the least value of y, and where y is a digit. So the least value of a digit is 0. So obviously the answer is y equals to 0 is the least value of y that will make the given number divisible by 18, and in that case x has to be 2. Nothing is said about x, which means that you can consider x can have any x can be any required digit, but the condition is that it is asking what is the minimum value of the digit y that will make the given number divisible by 18. And we can see that if we consider y is equal to 0, we have found that y has to be even, because the given number has to be divisible by 2. So the digit at the units place of the given number is y, so y has to be even. In that case, y can be the digits 0, 2, 4, 6, 8, and 0 is the minimum value of y. And we can clearly see, if we put y equals to 0, we can clearly see that the number will be divisible by 9 if we consider x equals to 2. Okay, so the correct choice is B. So this brings to an end in solving these are good set of problems that will judge your understanding of the concepts of tests of divisibility of a given number by the numbers by some another number. So we have, in the previous video, we have discussed about tests of divisibility by the numbers 2 to 11. So using those basic concepts of divisibility by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we have to solve a problem to check whether a given number is divisible by any other number, and any other number you have to factorize it into some factors where the factors should not have any common factor, and those factors will eventually be one of the numbers from 2 to 11. So I hope this set of problems will give you will help you to it will be a good practice on your concept of tests of divisibility from the chapter of playing with numbers. So if this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about the topic of replacing letters with numbers. It is a kind of game or puzzle kind of problems where you will be given some operations of some numbers where in the numbers some digits will be missing. They will be replaced by some letters, and some operation will be given that two numbers when added gives another number, and based on the result you have to identify those missing digits in the given numbers. So please stay tuned for the next video, and I will also start preparing and solving 10 good problems on this chapter playing with numbers that will be uploaded in the another playlist, which is Maths 8 Hot. Hot means high order thinking problems. So thanks for watching, and until the next video, take care and bye.